Okay, so today we're going to continue with section 4, part 2. We're going to be factoring perfect cubes and grouping. Now, the factoring of the perfect cubes may be something you may not have seen in your Algebra 1 course, so we're going to go through it. I'm going to teach you a nice little acronym to help you remember. Again, you have a test next Tuesday, and it's going to cover sections 2, 3, and 4. So let's go ahead and see what factoring a perfect cube looks like. So when you're going to be looking at a problem to determine if it's going to be a perfect cube, the first and the last terms are going to be perfect cubes. Now you're going to need to memorize these patterns that I'm going to fill in. Now notice for the cubes, there's actually both a sum and difference. So the first pattern, when it's a sum of two cubes, you're going to put u plus v. So you're going to be cube rooting the u and the v, and that's what's going to go in the first parentheses. Then you're going to take that u value, you're going to square it, you're going to put an opposite sign of the original, and then you're going to square the v. That's the first pattern you need to memorize for the sum of two cubes. When it's the difference of two cubes, the first one is going to have the same sign as the original problem, so subtraction. And then for the second, the trinomial, you're going to square your u, opposite sign of the original, so now it's plus, times uv, and again plus v squared. That last one in front of that v squared will always be positive. So what we're doing here, for example, I'll just show you with the sum. So the u cubed plus v cubed, what we need to do is we need to take this term here and we're going to cube root it, which will then turn into just plain u. And then for the v cubed, we're going to cube root that one as well, which turns into just v. And then from there, we take this u and this v, and we start to place it into the pattern. So again, for the sum, we would take the u, same sign, plus the v. Then in the second parentheses, you square the u number, opposite sign of the original problem, so subtraction here. And then we're going to take the u and the v, and we're going to multiply it. And then the last term is always positive. Actually, let me do this in color. So this would be u, this would be v in blue. And then the last term will always be positive, and it's the v squared. So that's the pattern. The acronym I have for you is the first sign is the same as the original. The second sign is going to be opposite of the original. And the last sign is always positive. So my acronym is the word SOAP. So we're going to spell SOAP. Same sign, that's the S, and then opposite, and then always positive. And that's how you'll know what signs to go in here. Because if you notice, in both patterns, the letters are exactly the same. What's changing are the signs in between each one of the terms. So let's try our first example here. The x cubed minus 125. So here's where it's going to pay off if you memorize your perfect cubes. So I'm going to cube root the first term. So the x to the third, I need to cube root it. And out of that comes an x. So that's my u, if you want to think of it in terms of your pattern. Then I'm going to take the 125. Don't look at the sign. Just take the number that's there. You're going to cube root it, and this will become my v, and it's 5. So now I'm going to take my new u and v, and I'm going to plug it into the pattern. So this original problem was the difference of two cubes. So I'm using this pattern. So I'm going to go ahead and do same sign. So I'm going to do x minus 5. And let me do it in color. Hold on. I'm going to do x minus 5. That's the first parentheses. And then now the first term here is going to be this x squared. So that's what goes here. Then opposite sign of the original problem. And then the next term is going to be this times this. Don't look at the sign, just take the number. So this becomes a 5x. And then the last term is the 5 squared. And I would write 25. So this is 5 squared. This one was the x squared. And then the middle term was x times 5, or u times v. And then you're done. So these cube patterns, the trinomial that results after you factor it, cannot be factored. And what we're going to do tomorrow is factor trinomials. So that trinomial that results in the factoring of the cube cannot go any further. So here's my acronym. Same sign, opposite, and then this sign's always positive. Let's try some. Pretty good here? All right, next one. So again, let's cube root the first term. So I'm going to take x to the third, cube root it, and then my u here is just x. The v is going to become the 27 cube rooted, and v equals 3. Now I'm going to put it into the pattern. So remember, the pattern is, it's a difference, so it's going to be u minus v, same sign, u squared, u times v, and then plus v squared. So let's plug it in. So same sign, so x minus 3. I'll make the 3 blue. And then the next parentheses, you square the x. The next term, opposite sign, but I multiply the 3 times the x. And then the last term is always positive, and it's the 3 squared. And you're done. So this was the 3 squared. This was the x squared. And then this term was, I wrote it backwards, this was just the v times u. But you're taking these two and multiplying them for that middle. And again, use your acronym. Same sign, opposite, always positive. Let's try number 2. It's the sum of two squares now. So again, to get my u value, I'm going to cube root y to the third. So u is y. My v is going to be the cube root of 8. And my v is going to be 2. So now let's put it into the pattern. So I'm going to do y, same sign, plus 2. And then now I'm going to square the y. I'm going to multiply the u and the v, which is 2 times y. So then that becomes opposite sign. Think soap. So 2 times y. And then the last term always positive, and it's the 2 squared. So again, soap. Same sign, opposite of the original, always positive. Let's try the next one. Cube root the 64x cubed. So this becomes 4x. That's my u. Let me trace over it in red. And then the v is going to be the 1 cube rooted. So v equals 1. So now let me put it into the pattern. I'm going to put it below here. So the pattern, you're going to do u, same sign, so minus the cube root of 1, which is 1. Now, when you square this one, the number that's going here, or the term that's going here, is this u value squared. So this becomes a 16x squared. Because not only are you squaring the x, you're also squaring the 4. Opposite sign, multiply the 4x times the 1, and that gives me 4x. And then last, always positive, 1 squared. So this is 1 squared, and then this one was the 4x times the 1, and that's how you got that one. And you're done. Let's try the next one. If you recognize that in number 4, these are not perfect cubes, but always, 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 you should look for a greatest common factor first. So I could factor out a greatest common factor here of 3. So I'm going to do that first. And now what results are 2 perfect cubes. So to get my u term, cube root the x cubed, this gives me u equals x, cube root the 64, and my v equals 4. And now I put it into the pattern. Do not forget about the GCF. So put the 3 in front, and then now start your pattern. Same sign, x plus 4, square the x, multiply the x and the 4 for the middle, and this is opposite sign. So we're going to do 4 times x, and then the last term always positive, and it's the 4 squared. And you're done. So it makes it a lot easier if you memorize the pattern. We good with number 4? Let's do some more. Number 5. 2 cubes still. So let's cube root the 3x to the 3rd. So my u term is going to be 3x. My v term is the cube root of 1. And we put it into the pattern. So this will become 3x. Same sign. Cube root of 1 was the 1, and now square, remember this next term is really 3x squared, so this becomes a 9x squared. Next sign is opposite of the original, and remember we're going to take the 3x and times it by the 1, so this next term here is just 3x. And then the last term always positive, and that's the 1 squared. And you're done. So there was no GCF to pull out, so that's all I needed to do here. And again, the trinomial that you get after you factor the cube can never be factored any further. So if it's a perfect cube, you may have a GCF at the beginning, and then you put it into the pattern. Let's try number 6. No GCF here. Let's just do our pattern. So we're going to cube root 64 y to the 3rd, which gives me 4y. Cube root 125, and I get 5. Put it into the pattern. 4y And then same sign, so minus the v you just got. And then remember this term is the u squared. So again, the 4 gets squared and the y. And then the next term opposite of the original. And remember it's u times v. So it's 4y times 5. So what's going to go in here is going to be 20y. And then the last term is always the v squared. It's always positive. So this is plus 25. Now the next one's a little different. It's a bit challenging. Pretty good on 6. Number 7, we have 2 perfect cubes here. But notice my first perfect cube, this u term here, u, and actually I'll just write it here in red. Once I cube root x plus 2 cubed, I end up getting my u term to be x plus 2. My v term is just y. And I'm going to put it into the pattern. So I'm going to be doing x plus 2, same sign, and then the v. And now for the next one, I need to square the u. I'm going to put it in as x plus 2 squared. I'm going to have to FOIL this, but for now, let me just put it in. Then the middle term, opposite. And again, the middle term is made up of multiplying the u to the v. And then the last term, always positive, and that's just going to be the y squared. So same sign, opposite, always positive. Now I need to simplify that second parentheses. So I actually have to FOIL this one and distribute this one. So the first parentheses is done. Nothing changed there. I'm going to leave the x plus 2 minus y. But the next parentheses, I'm going to FOIL this. This becomes x squared plus 2x plus 2x plus 4. So when I add those, I get x squared plus 4x plus 4. And then this middle term, I'm distributing the y. So xy plus 2y. And then the last term is just the y squared. Now, it looks like a big old mess here. There are no like terms to combine here, so that's my final answer. The order here wouldn't matter. You don't have to do it like this. I just put all my numbers and letters in here the way I multiplied it. So that is it for factoring the cubes. Now we're going to switch to the factor by grouping. And again, you should have done this in your Algebra 1 class. Pretty good? All right, let's try that. So when you factor by grouping, you're going to have 4 terms. You're going to group 2 terms at a time, so you're going to make pairs of them. Then you're going to factor out the GCF until the parentheses match. Then you're going to factor out the parentheses. You're going to group together the remaining terms. So let's try it. Now, it doesn't matter how you make your groups. If you want to rearrange these 4 terms, you can. You're going to get the same answer either way. Now, some teachers teach this method for factoring trinomials. This is what I like to do because you can stay consistent. But for right now in the notes today, the problems are all going to have 4 terms. So we're going to make groups. So I'm going to take Let me rewrite my problem here. So x to the third minus x squared plus 2x minus 2. So I'm going to group the first two and make a pair here. And then I'm going to make a pair here. So that's the first, so 4 terms, group them into pairs. Now what I need to do is factor out a GCF of the red pair and then the GCF of the blue pair. So the GCF of my red pair is x squared. So I'm going to divide this by x squared and this by x squared. And then I'm left with x minus 1. Now I have to look for a greatest common factor of the blue pair, and that GCF is going to be 2. So I'm going to put here positive 2, and then the answer to the division. Now, whenever you do factor by grouping, these parentheses that you get after you divide must match. So these two things must have the exact same thing in there, or you have to go back and maybe you should have pulled out a different GCF or maybe a negative GCF. They must match. Once they match, you're going to take the GCF or the thing that they now have in common. You're going to write it down once, and then you're going to take the 2 GCFs that you found, and that goes in the other parentheses. And you're done. You can always take these binomials that you just found and you can FOIL them or distribute them, and it should go back to your original. Let's try it. So if I FOIL, I'm going to multiply this times this. I get x cubed, x to the 2, 2x, and then negative 1 to the x squared, negative 1 to the 2. Notice it's the same thing, it's just in a different order. So it's still the same original problem. You just have to switch your terms around. Now, when you're writing your answer, you can either write it this way. The order of the binomials doesn't matter. I could put the x squared plus 2 first and the x minus 1 second. So the order of your 2 binomials doesn't matter. Now you don't have to FOIL to check. If you have time at the end, definitely do that. Let's try a couple of examples and then we're done. So again, you should have done this in your Algebra 1 course. So let's try it. Again, you can leave it the way it is and just put parentheses around the first 2 and then the second 2. Or if you want to rearrange them, that's totally up to you. You still get the same answer. I always just leave it the way it is. So I'm going to make a red group and my blue group. I'm looking for the greatest common factor of red. The greatest common factor between 8 and 6 is 2. And they also have x's in common, and it's the x squared. So I'm going to do the division. 8x to the 5th divided by 2x squared is 4x to the 3rd. Remember, you subtract the powers. And then I'm going to divide this, and I get 3. Then for the blue group, my GCF here is going to just be 3 because the 9 doesn't have a variable. I'm going to divide. And notice the 2 things I got after I divided in the parentheses is the same, so I factored it correctly. I now take that thing that's in common, the 4x to the 3rd minus 3, write it once, and then take these 2 numbers that are outside the GCFs that you divided by, and it goes in the other parentheses. And you're done. And again, if you'd rather write the 2x squared plus 3 first, and the 4x cubed minus 3 first, either way, it doesn't matter. Try the next one. Red group, blue group. Now, on this one, be careful because remember, what ends up in the parentheses must be the same. So the GCF of red is going to be x squared. So I'm going to divide, and I get x plus 1. Now, if I only pull out a positive 5 GCF here, watch what happens. I end up with negative x minus 1. You see how these don't look the same? So in some Algebra 1 classes, they make you pull out the positive, and then they make you go back and pull out a negative 1 as well. I like to just pull out a negative GCF if this happens. So if instead I pull out a negative 5 GCF, then my two parentheses are now the same, because negative 5x divided by negative 5 is now positive x, and then negative 5 divided by negative 5 is now positive 1. Again, take what you have that's the same, write it down, and then again, take the two GCFs and group them as well. Again, remember, you can always FOIL it. If it doesn't go back to the beginning, you've done something wrong. Let's try number 10. Again, I'm going to make two groups. Again, if you'd rather rearrange, you can, but I'm leaving it the way it is. The GCF of my red group is going to be x squared. Divide GCF of blue. Again, if I pull out a positive 5, the parenthesis won't match. So I'm going to pull out a negative 5. So at this point, if the positive GCF doesn't work, resort to the negative. If that doesn't work, then potentially you might not be able to factor by grouping. But all these you can. Again, it looks the same. So then you just write down the x plus 5 as well as the two GCFs you divided by. And you're done. Last example. Again, I'll make a red group and a blue group. GCF of my first group is x squared. Divide it out. Left with a 3x plus 1. GCF, again, I'm going to pull out the negative 5, so the parenthesis looks the same. And I'm left with 3x plus 1. Again, these look the same. Write it down. And again, group your GCFs. And that's factor by grouping and factoring perfect cubes.